Last class we solved this one. Now today we'll talk about the floating body, stability of floating body, and when a body will sink or float. Okay, and you already have some idea from the your knowledge of your college about the Archimedes law and the buoyancy force, but still we'll discuss a little bit that what is the condition of a body when it will float in the fluid or it will sink. And sometime a floating body, there is a condition of stability when a floating body remain in static condition or stable condition. For example, you're traveling Dhaka to Borishal in a boat or launch, and you have a storm in the river, and sometimes they call the, okay, please go down, instead of staying in the roof. But normally people, what they do, they try to go to the roof of the launch, but it also destabilize the boat. Okay, so but they request the people without knowing the reason. They just say, but it has a valid reason that if you during the storm, if you are able to loaded the ship or boat at the lower level, the boat will be more stable. Okay, and we'll see it mathematically. Okay, now let's discuss about some fundamental term or definition. Number one thing, what is buoyant force? When a body immerses in a fluid, either fluid is fully or partially, the body might be immersed partially or fully, it experiences a vertical upward force to the opposite direction of the gravity, that means opposite direction of the weight. And this fact or phenomena is known as buoyancy, and the vertical force act on the body by the fluid is called buoyant force. Okay, so over here, two definition: what is the buoyancy and what is the buoyant force. And buoyant force always work upward. We can, this lecture we can denote by FB. Now, center of buoyancy, the point through which buoyant force work upward direction, that is called center of buoyancy. You have a different type of object, say you float a brick type object, or that means rectangular object in a water, then its buoyant force might work through the CG of the body. It depends on, so buoyant force working right over here and weight working downward. And in that case, both might be work at the same point. Okay, but if concentration of the brick is not uniform, say some area of brick, this portion have a little bit higher density. Say this is a kind of wooden block, and this portion has some vacuum inside, air bubble. Then this portion have a density more. In that case, the weight will move a little bit left direction, right? But buoyancy force will, what happen? Say you put in the fluid in the bucket of water or in a lake, this much same volume of water has to displace from the bucket or from the lake, right? You could move, say you put the brick or a wooden block in the river, and initially say it is submerged. It is not going at the bottom but remain inside the water. So this is your free surface. So what happened? That means he displaced some fluid by his volume, right? Volume means same size of the object. So the buoyant force will work through the center of the displaced volume, center of the displaced volume. So that's why the buoyant force and the CG of the weight of the object, sometimes you might see they're not working or passing through the same point. Okay, and it has significant effect on stability of the body. And we'll discuss this later on. So just remember that the buoyant force works through a point which is known as center of buoyancy. What is the Archimedes law? Archimedes is saying when you submerge a body or you put a body in the fluid, then how much force he'll experience? He's saying a body immersed in a fluid experience vertical buoyant force is equal to the weight of the fluid. It displaces. That means if you keep a sphere in a football in a river lake, say made of stainless steel or cast iron, so the volume of water displaced by the ball will be volume of the ball, right? Then if you keep a brick, then it is volume. Volume will be length, height into thickness, right? So that argument is saying that the weight of the fluid displaced by the body, that mass will be the force body will experience when you put in the fluid. So weight of the fluid is also force, right? Mass is kg unit. So if you have volume, you can figure out the weight of the fluid equal to rho g v, right? Rho into volume, you get mass. I'm sorry, you get mass, then you multiply by the g, you get the Newton. That is the weight. Weight is actually force, unit is Newton. And we can mathematically prove it by, say, a horizontal vertical body is a body is sink under water. Okay. Now, if we take we think a small segment of this body, the segment is like a vertical rectangular strip, or you can say rectangular rod. So at the top surface, right, we'll experience some pressure. Pressure will be downward, right? Then at the bottom surface, we'll experience pressure. If I think this is the top surface of the water, so obviously this bottom portion pressure will depend on this height. Say this one is Z2, and top surface pressure will experience depends on this much distance, right? So how much will be pressure over here? I can say P equal to this over here, P equal to rho G Z2, right? How much will be pressure at the top surface? This one, if I say P1 equal to rho G Z1, right? This is P2. So if you multiply the area, you'll get the force. So force working at the bottom, I mean upward direction, the force will be rho G Z2 into area of this little box, area dA. So I am saying this dA. This much force working upward, right? So this is, I'm saying F2. Similarly, working downward force equal to rho G Z1 dA. Now, what is the actual force working in the body? Difference, it has some weight, right? Weight also working downward. So difference of these two force will be equal to the weight of the body. It is remain right there, right? Now, I am not considering the weight of the body. Archimedes is saying that upward force, buoyant force, is equal to the weight of the displaced fluid. So how much fluid actually displaced from there? Actually this much, right? This much fluid is displaced. So you figure out the weight. Now I will figure out the upward force. So upward force, resultant force, FB, or you can say FV, F2 minus F1. So rho G equal to gamma. I write down gamma Z2 dA into dA, right? This term minus will be gamma Z1 into dA. Now that means ultimately this one nothing. Okay, ultimately we are getting gamma. This force I write down there is working on the small portion of the body. You can say this is delta FB. So if you figure out the total force or the whole body, you have to do the integration. So FB equal to integration of P2 minus P1. That ultimately getting Z2 minus Z1 into dA. Okay. So Z2 minus Z1 into dA actually what? Z2 minus Z1 actually the height of the body, and dA is the cross section of the body. So that means this one ultimately giving volume of the body. So volume of the body then multiply by gamma, you will get the weight. So this is given by Archimedes long ago. So this equation assume that body has a uniform specific weight. Uniform specific weight means density is uniform. Floating body displays on its weight in the fluid into which it float. So FB equal to gamma into displaced volume equal to, this will be equal to weight of the floating body, because this mass force working upward, but weight is working downward. So both has to be same. Otherwise, if weight is more, then it will go bottom floor of the river or lake. If both are equal, then wherever you keep, the object will remain there. Okay. If upward force is higher than the weight of the fluid, then it will float at the top surface. Okay. For example, if you take a little bit heavier, for example, a pen, you keep in the water, it will sink. Okay, because the volume displaced by the pen of the fluid, the water, how much volume it will displace? Diameter of the pen into length. Then you multiply by the gamma, rho g. You'll get weight of the fluid displaced by the pen. If that weight of the fluid is less than the weight of the pen, then it will sink. But if your fluid is more denser, say for example honey, then it might be sink, but it will sink slowly because fluid density is more. So vertical force working higher force. Then you put bucket of tar, alcatra. You put the pen, it might float because its density is more. So weight of the displaced volume of fluid become higher than the weight of the body, then body will remain in floating condition. Okay. Excuse me. Buoyant force acting on a body immersed in a fluid is equal to the weight of the fluid displaced by the body, and its act upward through the centroid of the displaced volume. Is moving upward through the centroid, not of the body, centroid of the displaced volume of fluid. Okay, it is known as Archimedes principle. So for floating body, the entire weight of the body is W, and buoyant force is F, FB. So what will be the W? W, I'm saying weight of the body. So if body volume is V and density is rho B, then you multiply by the G. This will be weight of the body. Now, if you submerge in the, put in the water, then might be 20% underwater, might be 40%, or might be total volume. So this one we are saying total volume of the body. So weight of the body equal to rho B G V total. This is the weight of the body. Now, buoyant force will depends on volume displaced by the body. For example, keeping a boat in the river. River, say right over here is propeller. So in that case, what will be, how much will be buoyant force? Buoyant force will be how much, if this is a free surface, then how much volume of water displaced by the boat. That means this much. You get this area, then you multiply by the width of the boat, right? If I think just the boat is like this one, okay? If this, I'm looking from this side, we will not see like that, right? So you have this area, this bottom area, then is multiplied by the height, you'll get the volume. This much volume will be displaced by the boat. So this volume, I am saying V sub. V sub means submerged in water or fluid. And this total volume of the boat or ship, that one I am saying V total or VT right over here. Now, so how I can figure out the weight of the fluid displaced by the boat? Only this much volume, right? So I know the volume inside the fluid or water is V sub. Is V sub, then you multiply by the water or density of the fluid into G. That much force will work upward condition, and that will be equal to FB. FB means buoyant force working upward. Okay. Now, if a body float in the water, then what will happen? These two will be equal, right? Now, it says submerged portion of the body is equal to the buoyant force. The buoyant force equal to weight of the fluid whose volume is equal to the submerged portion of the fluid. So now submerged portion of the floating body equal to the volume of displaced fluid. So this is the main equation, because force working upward has to be equal to the weight of the body. So this is the weight of the body and this is the force working upward direction. So it's I have a sphere you put in the water and it's floating. That means total volume is the VT, and this much volume is submerged. That is V sub. Okay. So body of the total weight, total volume into density. Then weight of the submerged portion of the fluid will be volume of water. That means submerged portion of the body into density of the fluid. So now you say the FB equal to W. Now you put like that, you will see G and G will be out. So total volume by submerged equal to rho F by rho B. So from here, what you see, left portion will be always higher than 1, right? The total volume will be always higher than submerged portion, underwater volume, right? So if this one is higher than 1, then this ratio will be higher than 1. What is this ratio? Density of the body by bottom density of the body or density of the fluid. So from here, what you see, density of the body is less than the density of the fluid. That means for a density of the body, if it is less than the density of the fluid, then it remain in static condition, in floating condition, under a fluid or under water. So a solid body dropped into a fluid will sink, float, or remain at rest at any point in the fluid, depending on the density relative to the density of the fluid. That means if density of the fluid is less than density of the fluid, then remain in floating condition. If density of the body is equal to the density of the fluid, in that case, you keep inside, say you keep it right over here, it will stay here. It will not move upward, move downward. Okay. And if density of the body is higher than density of the fluid, then the ball will come in the bottom of the river. Okay. Right over here, you see in this case, floating body, like a boat. Like you make a ball, same volume with some foam, then with stainless steel, then with lighter metal, might be aluminum or might be inside some vacuum. So in that case, floating, this will be float because density of the body is less than density of the fluid. Then this one is called suspended body, because this body, you move somewhere, you're moving over here, it will stay here. You're moving down right over here, it will stay here. And if density of the body is higher than density of the fluid, then will remain in sync. Okay. Are you able to hear me? Hello?
Yes, sir.
Okay. After a few minutes, our session will be finished. And then I have about 6 minutes now. Okay. And in the right side, you see that how weight and the buoyant force is working. So this body, you keep underwater, that means this much volume of water is displaced by the body, right? So this much volume of weight of the water will work upward, and weight of the body will work downward. If both one is same, then it will remain under water. Underwater means it will not come to the top surface, it will not go to the bottom surface, it just remain inside the water. Okay. Now, how we'll consider a body is stable or unstable? Something like, if you look to the right side body, this is unstable because You move the ball a little bit, then it will fall down. You keep moving this way, it will fall down. And this one is neutrally stable. You move a little bit, it will stay here. You move to left, still here. And this one is stable condition because you move the ball, it will come back to the previous position. That is called stable body. Now, we will see how a body remain a stable, unstable, and neutral condition or neutrally stable condition in case of a boat or in case of a floating body. Okay, so let's take it in the next slide. Okay, number one, stable condition. It's a rotational stability of an immersed or submerged body depend on the relative location of center of gravity, because weight will work through that point of the body, and center of buoyancy, which is the centroid of the displaced volume. An immersed body is stable. A body is bottom heavy. Bottom heavy means at the bottom it has more weight, and the CG is directly below the point B. Point B means through which buoyant force is working. A rotational disturbance of the body in such cases produces a restoring moment to return to the body to its original condition. So this is the example of stable condition. How? Say a ball in the bottom portion little bit heavier, so weight is working downward and through the center of gravity, and buoyant force is working upward, but both 2 points is in the same line. If you make a line, it will be they are concentric or working line of action is same. Now, this body, if any reason, say you put in the water, it roll, that it can roll left or right, any side. So if is roll little bit right direction, that means say any reason due to the wave is roll like that. A wave coming from this side with sudden high velocity, body is become inclined. If body is become inclined, that means previously right over here working my buoyant force inside the body and weight working downward. But when it is become inclined, then direction of this force remain the same. This FB working like along this direction, but due to the body movement, the volume of water displaced by the object is not same as previous position. Because, for example, you are in a boat, boat flying straight. So how much volume is displaced, how much volume underwater, different by the area, right? But say due to the wave, it inclined. Now, your water displaced by the body is not the same as previous one. It is displaced. So that's why you see the buoyant force magnitude will be changed, and also the weight or center of gravity you will sense of the body due to the rotation. So it's coming now right over here. Now what you see, they are not working through the same point of the body. This one working through this line and this one working through this line. So there is some moment working, right? This will try to be rotate the body along this direction. So the wave try to rotate the body along this direction, and it rotate. But due to the restoring moment, immediately body will become straight, also will become straight. So that's why it is called stable condition. And so I was trying to explain that how restoring moment work. Now, if bottom of your body is heavier, then CG will not displace, right? It remain at the bottom. As a result, you will get a restoring moment. So that's why when you traveling in a boat, you are going Dhaka to Borishal, you have a storm, and normally people try to go to the roof. But if you're staying at the bottom, then bottom of the boat or ship will be heavier. So due to the wave, if boat become inclined, then after wave gone, then it become stable condition. It will become straight. But if top become heavier, then it will be upside down. It will be capsize. It will not come back in previous position. Okay. Now, neutrally stable condition body. In that case, right over here, in that case, what will happen? Due to the wave, a boat remain inclined a little bit. It will not come down, come back to the previous position. It will remain in inclined position. because there is no restoring moment. But if a body has higher weight at the top, then what will happen? CG will be top of the buoyancy center. That means your buoyant force working from the bottom of the body, upward direction, say right over here, is working FB. And weight of the body working downward through this point, it is W. Now, the storm came in. And due to the storm, this CG and FB will move. They remain in same direction. This is upward force working buoyant force, and right over here it inclined to this direction. Due to the wave, it rotated a little bit clockwise, and W working along this direction. Now, what did you see? Your FB working upward and W becoming downward. Right over here working downward, both same direction, but they are working along the same line of action. But right now, line of action is not the same. So these two will create some, this is equal force working opposite direction, and their action is not going through the same point. That means they will create some moment. So that moment, you see this one working downward, this is upward. So this will try to move more, rotate more. So due to the wave, the body is inclined a little bit, then due to the restoring moment, not restoring moment, destabilized moment, it will go back to, that means it will incline more. There is no possibility the boat will become straight. Okay, and we can explain it more later on, that how a boat is sink and how we can minimize. That means how we can design a boat with more stable condition. Okay, so it's a neutrally stable condition. It's saying an immersed body, neutrally buoyant body, buoyant means floating, is neutrally stable if center of gravity and center of buoyancy are coincident. Body may not return to its original stable condition after small angular displacement or no restoring moment exists. It's saying in this case, if body is getting inclined a little bit, body remains the same condition, but it will come back to previous condition. That is saying that a small angular displacement or angular rotation due to the wave or other reason. Okay. Then unstable condition. It's saying this one. It's saying immersed neutrally buoyant body, buoyant means floating body, is unstable if center of gravity is directly above the center of buoyancy. A small angular displacement causes further increase in rotation, angular displacement rotation by overturning moment. That is moment is called overturning moment. This one is called restoring moment, and this one is called overturning or unstable moment, because it will try to make more rotation. That's why it is called overturning moment. Now, right over here, there is some parameter or some definition. By fixing that certain parameter, you can make a boat more stable, and you can avoid the overturning moment. So it's saying the measure of stability for floating body is the metacentric height. What is the metacentric height? It's a GM. If you look in the middle figure, this height GM is called the metacentric height. This M and this GM. Right over here, this GM, distance GM is called metacentric height. Now we need to know. That means this distance, by measuring this distance, either it is negative or positive value, you can figure out that whether my boat is have a restoring moment or it will float with overturning moment. Okay. So what is the GM? Which is the distance between the center of gravity G and the metacenter M. Now, what is the metacenter? The intersection point of the line of action of the buoyant force through the body before and after rotation. So this is stable condition before rotation. Okay. And now this one is also stable, but due to the rotation, you see the buoyant force is moved toward the right. Is inclined toward the right. That means he's displacing more fluid on the right side, right? This portion getting upward, moving upward. This portion moving downward. That means this portion will remain more in the water, not this. Still there will be some water, but volume will be less due to the incline. So that's why center of buoyancy is moved toward the right. So it's coming over. The longitudinal axis of the board right over here, it remains the same. And this buoyant force line of action, you draw a line, it intersects with the central axis at point M. This M is called metacentric height. And this distance between the metacenter and center of gravity is called metacentric height. So right in this case, you see that G working along the direction, weight of the body, and buoyant force working upward, right, through this point, and weight working this point. So you'll get some moment to become stabilized again. That moment is called restoring moment. But right over here is unstable body. So you see, due to the wave, it become inclined a little bit. So, but B working right over here. Okay, what is the difference over here? You see buoyant force working right side of the center of gravity. Now buoyant force is working through left side of the center of the gravity. So your CG working through this point and buoyant force working through this point. So this case, you are getting a moment that is working clockwise. That means it will try to, it will not help, it will try to sink the body. So that is called overturning moment. And this one, this is working downward, this is moving upward. So overturning moment will be anti-clockwise and try to stabilize the body. Right, what is saying, a floating body is stable if M, that means metacenter, is above the CG, thus GM is positive. For it will be unstable if M remains below the point G. In that case, GM is negative. In later case, that means this one case, weight and buoyant force acting on the tilted body generate a overturning moment instead of restoring moment, causing body to capsize. The length of the metacentric height, GM, G is a measure of stability. So it's a, the larger the GM, the body will be more stable. You need to keep the GM as much as possible bigger. So if GM is negative, then it will not help. You will have more overturning moment. If GM is positive, then you have restoring moment. Now, what is the application of this one? Anyone? Anyone? Storm your brain. What is the application? Okay. You traveling Dhaka to Borishal, right? You have storm, even the people in the boat or in the on board or in the ship or launch, they will say, okay, could you go to the bottom? But I will not be agree, right? Because we are human beings, we try to save our life. But is the huge ship, say, loading in Singapore or in Beijing, and it will go to the Europe, okay? Those big ship has a huge number of containers, and weight is also too much, right? And the humongous size, that means bigger size ship. How they loading? They have a spec of all the container. They use some sensor measurement equipment. They use the size of the container, volume of the container, and also weight of the container. Then they have a, they know that where is the CG of the empty boat, okay? Yeah, with all the equipment. Then they use a special software, and they got a higher salary, you know. They distribute all the container by a software to make sure that this metacentric height, they try to keep as much as possible bigger, okay, to get the restoring moment. That is the application. They put a container, then run the software. Let's see what is the condition of the ship of the restoring moment to keep the CG in certain level. Similarly, in the aircraft industry, say they have capacity 300 passengers. Now they got only 60 passengers. How they will distribute in the allocation of seat? They'll not keep all of them at the front or at the back side. Even you have a, say, 10 people in the business class or first class, and 60 of them in the economy class, or it's called third class, but they will distribute informally to make sure that there will be that much effect of location of CG of the airplane, okay? how the airplane work. If you look at the front section of the aircraft, say looking at the front, this is your aircraft wing in the both side. I'm sorry, this will be like that. Okay, so when this fly, the pressure at the wing work upward direction. Okay, so resultant force should work along this direction. Now CG, you are keeping over here, then you are travel. You are keeping left side, then you are travel. So try to keep the CG at the same line of action of the upward force coming from the wing pressure from the bottom of the wing. Okay, so that is the application. A ship is floating or in movement over a fluid, right? Water. Same thing, submarine running under the water. Same thing is floating body, right? How they maintain the height of the submarine? You gradually keep some water, it will get wetter, go down. You like to coming to the top surface, by the palm you take out all the water. Okay. Same thing, a airplane, a missile is traveling inside the air and inside the fluid. This is also a floating body. Okay. And remember, Sunday we have exam.